I'd like to welcome everyone to the September Mississippi PowerShell User Group meeting. Tonight we've got Kevin Marquette, who's going to be presenting on PSGraph. I'll turn it over to you, Kevin.
All right. Well, thank you for the intro. Like I said, I'm Kevin Marquette. I'm a senior DevOps engineer for Loan Depot. I've been probably working in IT and doing automation stuff for like 15 years. I kind of got my start in Lincoln, Nebraska. I was working the help desk, and I just had this passion for technology where I started bringing more and more automation into what I was doing, and I kind of just worked up the ranks through that. And PowerShell has really allowed me to progress my career quite nicely. And so I've always been passionate about automation and PowerShell. And so that's why I started giving back to the community doing talks like this one. And I'm also organizing the Southern California PowerShell User Group. One of my coworkers, David Christian, he's also helping me run that. And I suppose we can kind of roll off the talk here. The demo that I'm presenting is actually out on GitHub. I think I just refreshed it here a little bit ago. So if you want to pull the script to go along with it, or just have a reference material for later, it'll be online there. So PSGraph. Now, what I'm going to cover tonight is this is a module that I built. It's actually as a DSL, a domain-specific language, for generating graphs, like node edge-based graphs or hierarchical models. Think like an organizational chart. It's a type of graph that isn't always easy to script and generate on the fly. So what I'm going to cover today is GraphViz is an open source engine that I'm utilizing to do the layouts and the rendering. I'm going to introduce my module and all the basic commands and the various ways we can use those commands. And then I'm going to, like halfway through, we're going to shift into actually building graphs and scripting and generating them kind of on the fly or data driven. And that's where the real fun is. So to begin, GraphViz, like I said, it's a open source project that's really mature at this point. It's got lots of great documentation on it. And, the gallery gives a good representation of the various different types of graphs that it can generate. So as I'm talking about PSGraph, just know that it's leveraging this engine, and all the documentation and scripts that utilize GraphViz can also use my module. And with that, and I'll reference this a little bit as we go along here. So to get started, we need to install both GraphViz and PSGraph. I do publish this to the module, or to the PowerShell gallery. So if you don't have GraphViz installed, I'm pulling it from Chocolatey repo. And then same thing here, we can find module online. And let me adjust my output here a little bit. So just like any module, once we find it, we can install it, and then we will import it for the session. So 0.6.1, that seems appropriate. I think I've got like one round of bug hunting to do before I mark it a 1.0 release. But as I run this command, I've imported it. Here's a sampling of the commands that I've introduced. I'm going to walk these one at a time, and there's probably a few on here that I won't touch on, just because they dive into the deep depths of GraphViz. But it's a quick glance at what we got. So let's begin with a nice basic sample of a graph. So, like I said, this is a module implemented as a DSL, which means it's PowerShell-like, and I actually do have commandlets and commands in here, but it's very tailored to the idea of generating nodes and edges. So we have to define a graph, and in there we specify nodes. In this case, I'm defining a home node and a work node and giving it an appropriate name. And I'm defining an edge or a line from home to work. Then I'm taking the output of this graph and I'm piping it to this helper function called export PSGraph, which its sole purpose is to invoke the GraphViz engine. It does the layout and it produces the output files on the fly. So if we run this one here, so we can get a visual what it is. So we create a graph.png, my temp folder, and if we invoke this, we get this nice, simple graph that matches exactly what we described, right? We say node home, node work, and we draw an edge to it. So from this simple example, we can clean up just a little bit to know that the node keyword is actually optional. So just by specifying an edge from one node to the next, by calling it out here, our graph will automatically place the node where it needs to be. So here, I've decided to draw a graph from home to work, and then draw a line back from work to home. I've also condensed my export function to just use the show graph, and this will, on the fly, just pop the graph up so I can see it and do kind of quicker iterations. So it depends on your use case, right? Like if you're just trying to run something and see what it has, that's where I'd use the show graph. But if you are exporting the images for like a website or documentation, that's where it might make sense to specify the destination. You can actually specify both. So if I want to also save it to a file, a specific file, I can. If you're paying attention to my output window, it does actually generate an image in the temp folder every single time, and then it executes it. So if you do have a graph that's exactly the way you want it, you can save it or capture it right away. Quite often, another pattern, if you will, is to generate my graph and assign it to a variable, and then we can pipe that variable to the export graph. So what's happening behind the scenes is this guy's just building a string. It's translating these edge commands to the language that GraphViz uses. If you look at the specification website, they call it the dot language, DOT. And my DSL is heavily influenced by the GraphViz DSL. I tried to keep it very familiar. So if you're somebody that's coming from GraphViz, you should go just pick this up and run with it. If we want to look at what the output to this first simple graph is, it uses a syntax for edges, with a little arrow pointing from one to the next, and it uses slightly different keywords. As we get started, our simple graphs and the output will actually look quite similar. But as we utilize some more advanced features later on, we'll be able to use fewer commands to generate much more complicated dot expressions. So with that, we also support positional parameters for all the commands, which gives it more of that DSL feel. And this here is just as valid of a command as the full, from to syntax. And if you've done lots of GraphViz, this might actually feel more familiar. Not only can we do a from to on individual nodes, we can also build a chain where we connect an edge from A to B to C to D and back to A. So this one will basically create a loop we'll have two graphs on here, right? We'll have my home to work graph, and somewhere else it'll have this alphabet loop. So when we run this one, we get exactly that. Home to work, A to B to C to D. And like I said, I put the A at the end just to make sure it closes and loops back on itself. The edge command also supports attributes. So if you want to specify what attributes we're going to use, we can use a hash table, or we use a hash table to define the attributes that we want to apply to a specific edge. So in this case, I want my first home to work edge to have the label of car for some reason, and I'm going to color it red. The next one, just to show that it's different, we're going to color it blue. And so home, we're going to use the car to get to work, red, and blue to come home. I don't know if colors really represent anything, but it was easy to distinguish. As we take a peek at the graph language underneath, the reason why I chose a hash table to specify the properties is because that's very similar to how the dot language represents them underneath the covers. So like I said, if you're coming from GraphViz into this, the skills you know should translate quite easily. Node attributes. So while I said the node was optional, sometimes you actually want to give them a custom look. And that's actually why you would add the node, right? If you have no reason to customize the node, it's just as easy to just call edges from one thing to the next and leave off the node entirely. In this case, I'm going to have this home node, give it the shape of a house, and we're going to label it my house, and then we're going to change the label of work as well. Take a peek at this one. We have, like I said, the house node and the work node reflecting the descriptions that we want them to have. And I use the label is probably the most common label that I use, second to shape. I use them about the same. But it's so often that when your data, your information is driven from data, that your identifiers might be something simple like an integer or a GUID or like a username, and you want to give them a proper name when it's on the graph. So, and with that said, there are a ton of attributes. Like I said, because I'm leveraging the GraphViz engine, for free, we basically get access to all of the attributes that it provides on really describing how your things are colored. You can impact the size and the style and the fonts. And if you're wanting a unique look and feel, it's these attributes is where you're going to leverage to get it. if I run this one here, isn't, I don't think this guy's anything special, other than, you know, different font, different color, or a different color of font, I guess. And for reference here, I have the GraphViz documentation again that has just this giant page of attributes that can be used to customize various aspects of nodes and edges in your graph. So, I mean, if I just scroll past this, like, there is way more than I could cover in this individual talk on the attributes. But I just wanted you to know that if you're wanting something, it's probably available through GraphViz. So, oh, and then default attributes. So up above, I'm saying this node has this attribute, or that node has an attribute specifically. But you might find you have something common that everything should have, or across the sets. So if you use an unnamed node or an unnamed edge and specify attributes, everything past that point will pick those up. And I said that way because it's actually a top-down processing. So these nodes and edges, the definitions, if you will, define what everything that comes after this will look like. So here, we should get a bunch of boxes with purple edges. And that is exactly what we got. So you can see how, because I define an edge from node to node, without even specifying a node, I automatically put them on there. We get the shape and the colors exactly like we wanted it to be. And as I mentioned, you know, it's top-down processing. So you can start out with one default and halfway through switch to a second default. And I say it that way because you might have, when you're doing data-driven processing, you might have one large set of data or nodes or edges that you want to shove into the graph and look one way, and you can give them their defaults. And then below that, you have a second set that has a different style or a look. And you can basically redefine the defaults from that top-down processing flow. And at any time, you could override those defaults. So if we come down here and decide that, even though I've defined node, I can call out again and say, this time our shape will be this beloved house that, oh man, I misspoke. So I got to define that ahead of time? I might have to. I think I need to test that a little bit more. I thought for sure that'd work. Node shape. All right, moving on. Graph attributes. Okay, so far I've just talked about nodes and edges, and I mentioned that a graph itself can have its own attributes. So you can give it a label. The two most common ones I use is label to give it a description, and rank direction, left to right versus top to bottom. Everything we've done so far is top to bottom, but if I shift it left to right, this will shift sideways now, and we'll get home to work flowing from left to right. Then, all right, so now we shift into some more common scenarios here, right? So in this case, I want to make my graph a little bit larger. I want to duplicate some nodes. We actually want to say from home to work to lunch, come back to work, and then go home, right? When I run this graph, it's actually just going to create 3 nodes that flow into each other. And as I think through this, maybe that's not quite what I wanted to represent. What if I want more of a circular flow where I go from home to work to lunch in one path, and then come back through work to home? So let's see if we can break this guy out into separate nodes. Right, the most obvious way is to actually call it 2 different things. So we got work 1 and work 2. This way they're unique on the graph, but it has the obvious downfall and side effect of calling it work 1 and work 2, right? That's not quite what I wanted. So let's see if we can fix that. Let's get this saying just work on both of these. Let's go from, so what I'm going to do in this case is on my nodes, work 1 and work 2, I'm just going to change their label back to what I want them to look like. And this is the way you can get the same thing appearing at 2 different places on the graph. And you're still connecting from the unique ID that lives underneath it. So as I pull this guy out, right, I still have the issue that the flow feels kind of weird. But as I break this down, I'll often call this the node ID or the node name. And it's important to think of it that way when we get to data-driven graphs, and knowing that what's underneath doesn't have to look anything like what's happening out on top. All right, so let's see if we can get these graphs beside each other. And if the beauty of GraphViz is that you can dynamically generate and lay out graphs. The frustrating thing about GraphViz is that it's dynamically laying out your graphs, right? So when you get this point where you want very specific looks of the layout, there's some ways you can give it some hints on what you would like it to do. But if you want something very rigidly structured a certain way, you might find lots of frustration in making that happen. So I'm going to introduce the rank keyword. And in this case, what rank does, it just tells it, hey, these guys should be ranked equally. So get them like side by side on the graph, because they should be at the same level. So things that are ranked together should line up together. Take a peek at this graph. Sorry. We get that flow that I was imagining when I came up with this demo, right? This home to work, lunch to work cycle. And it's this line here where work and work should sit side by side and be aligned. And there's a second keyword here we're going to. It's called subgraph. So where I want to take a subset and group them into a smaller graph amongst the larger graph. So we call it subgraph 0. They're actually numbered. This is an artifact of the way GraphViz does their subgraphs. I might attempt in a future update to make it arbitrary labels and handle this behind the scenes. But just know for now that when you define a subgraph, they need to be labeled 0 numerically in order. But in this case, I have the lunch and work nodes in a subgraph, and my node out here that isn't specified, until I specify, I mean, that hasn't been specified, sits outside the subgraph. So let me actually run this example here, and you'll see that home, work, and lunch, or that my work and lunch nodes are boxed off separate from my home node. Okay, so I've kind of really ran through the syntax and some of the basic nuances of what my DSL looks like. And like I said, this closely aligns with the underlying GraphViz syntax, which I'm purposely skipping over GraphViz itself. But I suppose at this point, it'd be a good chance to, if you have any questions about, the commands that I'm using so far, and at least what we've done up until this point, feel free to ask your questions and let me know if there's something I should probably touch on a little bit more or review real quick before we go on to the next session. I'll check the chat for any questions, I guess. And I think we look good here. So let's actually build some graphs. And this is where the fun starts, right? Like, commands are one thing, but we could have done all that in just Visio so far. So in this scenario, let's build like a server architecture diagram. We're going to say, on the DMZ, we've got a load balancer, and we've got the web layer, and the load balancer talks to the web layer, the web talks to the API layer, and a database in the back end. Right? This is a fairly simple multi-tiered layout. Not all that exciting. We could have done in Visio and just as fast as it would have been to type that. But because we're scripting this, we get this point where we start specifying lists of nodes. So here, node also takes an array. And this array could be your list of server names. Rank as well will take an array. And edge will also accept an array. So in this case, I'm assuming that web 1, 2, and 3 are different server names at that layer. And the same thing for my API layer. We have multiple API nodes. And I can do array to array based edges. What's that mean, right? This lets me take every node in this side and connect to every node on this side. And so let's just get this guy in front of us so we can see what he looks like. So now I've taken what was a pretty boring graph and just substituted in place the web server nodes and actually have the same chart, but with one more closer layer of detail, right? So the flow is like this is that edge here. Let me get it back on the screen. This one here is that that matrix cross edge multiply. So I get edges from each and every one of these nodes, and this is where the PSGraph starts to show features above and beyond what you actually get natively with GraphViz. Because in GraphViz itself, you'd actually have to type out every one of those links from 1 to 2, 1 to 2, or sorry, 1 to 1, 1 to 2, 2 to 1, 2 to 2, 3 to 1, 3 to 2. And so that's one of the first powerful features that kind of drove me to start down this module. But then taking it to the next layer is, why am I even specifying all these servers in my graph, right? Shouldn't this really be data-driven? And that's where we start shoving all this stuff into variables. And we start making that shift from handcrafting charts that, honestly, up until this point, everything I've done, you could probably do faster in Visio by hand. But as we start creating structured data, And so let me run this here to make sure my variables are loaded. And then, as I describe my graph now, I can talk about it at a higher level, right? I've got web servers. My load balancer talks to web servers. You know, my nodes, my web servers talk to API servers. I get this higher level of abstraction that lets me, you know, craft something easier, just knowing that when I run this, those details take care of themselves. So when we run this time, I get the same graph, right? Oh, slightly different. I accidentally added a node down here, but you know what? It was easy to do. Let's make a quick change here. I think my API layer is insufficient. For some reason, we got 2 of these nodes, when really we probably should have had 4. And you know what? I think they broke one, so they're out of sequence, right? So now we load our variables. And then we jump down to our graph. We got a much more complex layer, and I was able to dynamically shift this graph now to show multiple nodes, where before I have to go move everything and draw these lines, or I have to go type in, you know, all those references to add new nodes. So this is where, you know, things start to get fun because, you know, this is just a variable in my script, but why couldn't this be data-driven, right? Like, why couldn't I pull this list from Active Directory or SCCM or Azure, you know, wherever my list of servers live, I can pull that in. So let's say I actually have that, you know. Let's say I've got all of my servers are in a text file, in this example, and I've got a lot of these guys. Now, this graph is going to look messy, but it's still the same graphs we had up above. So I'm going to quickly shove my stuff, my servers, into their respective lists based off of the role that we had. If I pull it back up again, I had the this data set. I go computer name, role, IP, and I'm going to come back and include this later, but just know that our data set includes it. And now when we run our web servers, I've got a ton of these guys. And I get back to my graph. This is the same graph I had before, same variables. And when I run this one, it's going to be noisy, but he automatically included every node, right? So when you decommission a node or add a new one, you regenerate this. He'll be current based off of the data that you feed it. So wherever you're maintaining your list of servers, your CMDB, your one source of truth, let it generate your graphs. Now, my data set included other data, right? And I had IP addresses, but it could have been about anything. And what I'm going to do in this case is the rest of this is still the same. My nodes, my API, my database. When I get down to the bottom here, I'm actually going to loop over all my servers. And for the node name, I'm going to call out the computer name. And the label, I'm going to do the computer name again, but also use a new line character, which that's the syntax. The graph is language, which is that uses that one. And we're going to inject the IP address in there as well. So now we generate this graph. And we kind of got something cool taking shape. So now I've got the IP addresses where I need them, right on the nodes themselves. I'm sure the first thing some of you might notice is that not all of these nodes are in order. And honestly, I have I've only scratched the surface of GraphViz, and this is one of those nuances where having exact control over what's generated can be kind of frustrating. So I haven't dove into GraphViz enough to have these guys show up in a sequential order. Like, that's just one thing I'm not familiar enough with the engine on how to do it. And I just want to set the expectation that these dynamically generated things won't necessarily lay out exactly the way you want them to be, but having them on the fly is what's so exciting. All right. So let's do one more cool thing here. Like, what if we're generating this on the fly and we can actually check the status of the server in real time, right? So I've got this mock test servers function that's going to say, is my server up or down? And I mean, it's random because I don't have that many servers to ping. But when I get down in my chart, I basically want to remind you that this is still a script block, right? Any PowerShell you want to write, you can still write your PowerShell in here. In this case, I did this thing where I did the, hey, test connection, right? Test server connection. Is it true? Give me green. If it's not, give me red. And then, since I'm looping over the server still for each object, in the attributes, I'm specifying a color to match the status above. So now, when I run this, I hopefully should have all green servers showing that everything's okay, or I'll get some red ones showing me where the problems are. So this guy, on the fly, I could be testing these nodes to see, what, we're missing some nodes, but we're not down. Like each tier here still has some enough green nodes that we don't have to worry. And if I want to run it again, showing it's truly dynamic, I got different nodes getting hit. And this is probably one of the coolest ways I've used it at work is for one specific project that talks to a lot of things. I have it not only check, the load balancer if it's green or up, but each server node, actually the application on the server node to see if it's up or not, and some of the URLs that it depends on. I also reach out, test those, and I pull all that information back into a graph that's similar to this, just with more, more information specific to Loan Depot. So like I said, just remember, this literally is a script block, and these are all getting executed one at a time. So any PowerShell you want to write and slip in here, you've got full power to do so. Okay, so I'm going to shift gears a little bit into like an org chart. Like this first chart, like we're still handcrafting how things are connected, and we have very distinct layers. But quite often, what you really want to do is take a set of data that has, maybe in this case, it's got an ID. This one's numeric. It could have been usernames, could have been emails, and managers. It tells me who the manager is. Right? This is that very typical, I'm going to generate an org chart, and this tells me who reports to who. This could easily be, Active Directory if you're using the managers, like who a manager is. That could be giving you this information for what we're about to do. So we got some high-level employees, and we got some low-level employees that get the work done. So let's close out of that. And then here, I'm starting with the default shape of rectangular. So I think these rectangular blocks look so much better than those ovals for something like this. I'm going to enumerate the people. And for each one, I'm going to use the ID as the node name, because these are objects, or at least lines of a CSV. And then my label will add the name and the title. so we can actually see who these people are. In this next clip, it says, hey, just take these same people, where the manager, right, is greater than 0 or true or false if there's a manager or not. For each object, let's just connect from the manager to the employee. So I'm doing a flow from top to the bottom, right? The CEO to his direct reports. And when we take a look at this, we get this beautiful flow that's automatically popped out and shows us, who reports to who based off a very, very simple set of data. And this is a pretty cool looking chart given what we had to work with. And I like to say that when you generate data, it shows you things that you might not have noticed in just a table of information. As I look at this, you can say, oh my, they're very manager heavy, like there's hardly any staff compared to the number of managers and directors and VPs in this org, so they're very title happy, aren't they? Now from there, we actually dive into one of my favorite features that I've added in GraphViz. And like this is very PowerShell, right? Like you see this, you know what's going on, and you're comfortable with this because this is how you think about enumerating things and executing them. But I see myself doing this a lot. Like this is a pattern that we see over and over when you're generating graphs. So I've added, I suppose, inline object enumeration. And what I mean by that is, let's take the same list of people, and I'm going to give node the entire list, right? Just give it the array of objects. I'm going to specify a script that is the node name of the ID. So it's going to execute this once for each node to get the ID. And the same for the label, right? I actually support the label as a script as well. And it'll run this once for each node as it's going through the list. So we're going to get the name and the title. This is equivalent to the previous example. So running this is functionally the same as running this, but it condenses it down from a loop to a single line. And the same for the edge. Or specify a node, filtered on manager, and we're kind of wrapping here, but where I do the from script is manager, to script is the ID. When I run this, I get the same chart. And I could probably leave that up, I guess. Yes, I get the same chart, the same graph as the more PowerShell, true PowerShell way, but our commands get just a little bit more inline. And in some cases, this just feels like the right approach to generating these graphs. But I'll admit, I back and forth depending on the need. I have plenty of graphs that show information just like this one here. But I've really started to leverage this syntax here, and I really like it. So I put a lot of effort into supporting both approaches, actually multiple approaches, for these commands. All right. So I suppose I'll checkpoint here. Is everybody kind of on page now? I got some more fun graphs of like real data that we want to look at. But if I'm going to check the questions here, if anybody has any. No, we're looking good. Okay. So other graphs. So now that I've got this module, it's been a real challenge trying to find, well, what do I graph with it? And in that quest, I do know I'm missing some things from this example that I need to find data sets for. Like I want to get to that users and groups or users and their managers from Active Directory. I just didn't have a clean enough AD to run these on for a demo environment. But we've got in our own system, on our box, we do have stuff that is relational or that can talk to itself, right? For instance, processes. Like every process in our system has a parent process ID. And the parent process might not exist anymore, but at one point it had an ID. So here's a real chart that will rank left to right, so I get this flow across the graph. And quite honestly, most of my charts do go left to right when there's any amount of detail to them. I mean, some simple stuff I can do top to bottom, but do things like server names or URLs in a graph, I find the left to right approach is just gives it a nice, easier to process and read feel about it. Again, I'm defaulting everything to a box. Common pattern that I have is that I like the box shape more so than the ellipses. And then here, I'm going to walk this line here where I'm taking these processes. Let's actually see these processes. Right? As I run this, we get the processes we all know. I filter it down to just the, I got a lot running on this machine. The name, the ID, and the parent process ID. And when I'm thinking about a node name or ID, I try to make it as close to whatever the parent ID looks like. Like if I can keep those the same, it makes your graph so much simpler. Otherwise, you got to find some sort of way to do a lookup table to translate it. So back to my example, I'm taking all the processes. I'm doing a node script that says the node ID should be the process ID. Then the attributes, as I scroll all the way over here, I want the label to be the process name. So ID, process name. Beautiful. And then again, the edge, same list of objects. I want to pull it from the parent process to the process ID, right? So this is per row of the process. We'll execute both of these to get our image. So now in, just a few lines of PowerShell, we're going to get this monster graph. If I zoom in on it, I kind of start seeing some cool layouts and patterns. So apparently, I have lots of Chrome tabs open, which if you know me, that is exactly accurate. And there's various other processes running. Now you'll notice that this is a giant graph. It pulled a lot of information on there. And we see some stuff hanging. Like I do, these guys here. Where's my lines at? I don't have any lines. If, let me do this. What's happening here is that the parent process ID has exited, but it's left the child processes running. So I don't have anything to tie these back to. So by the edge declaring the parent ID in the line, it will automatically create the node. So that's how we get nodes without descriptions. And something just to be aware of when you start seeing stuff you don't expect is, hey, maybe your edges are throwing in this extra data. So even here at the very top, right, I got a couple of these that are just kind of hanging there. Let's see, what else I got here? Ooh, network connections. Let me see my network connections. This, we can kind of get some interesting graphs out of that. And I'm just going to do connections from my box. Let me first make sure what my IP is here. 50.181, 21, local IP. I don't worry about you guys seeing that. So I'm basically going to filter out the the loopback adapters and the IP6 stuff. So I'm just saying, hey, where my local address is myself, give me a list of all those connections. And when we look at this data, we have a local address and a remote address and some ports. It's not hierarchical, if you will, but I think we can walk this from left to right, give me a rectangle. I'm actually going to splat this command in this time, just because it's getting so long to look at. So my node, and that's actually the name of that first parameter, is node netstat from our array. I want to say from the local address to the remote address. And then, since it's on an edge, I'm going to add a label that actually shows the local port and remote port connection. So, at a weird way, at a weird glance, at a weird glance, I can run this and see all of the connections from my machine to other machines on specific ports. So this is one of those ones where you might see multiple connections, like these guys here. I'm talking to them multiple times. I got loopback. I don't know. Those might be UDP. I'm not sure. I'll have to add that information next time. But I think it was cool how I just pull this network information and show it in a way that I can see how everything talks to each other. And I only got one node here, right? You could walk multiple servers, get this information, and put that on the same graph. So you can actually have this spider web of connections showing you what these important servers are talking to and on what ports. In fact, I think at work now, we're doing a lot of work with, firewall troubleshooting and issues, trying to get, working with infrastructure and DevOps on making sure our firewalls are doing exactly what we expect them to. And this would be one way to look at an existing server, an existing environment, show you what it's talking to, and kind of give us some hints on what rules might be needed going forward to other environments. Okay. So if I can connect network connections, part of the TCP connection tells me the process, right? And I can actually create a graph from our processes to the connections that are using them. Like, I think I was just talking to Mike about a scenario like this, where he's basically chasing down an issue on one application, and it turns out the different process is actually holding the fort. So we got node, rectangle, the node itself for each process. Let me back up here. So I am filtering this. I should point that out first. I am filtering the process ID based off of the netstat owning processes. Right, so when I run this guy, owning processes is a list of all the processes that own those connections. And then, so filtering that down to this guy, we go node process, the node script again, with the process names and label. For my edge, I do pretty much what I had before, right? Except now I've got the netstat node with the owning process to the remote address. I suppose this isn't quite the example that Mike had, but this is, what are my processes talking to on other servers? This very easily could be the local process or the local address, if that's what I wanted to show. But in this case, who are my processes talking to? Attributes, local port, remote port, beautiful information to have. And as I run this one here, I now see this nice visual of what processes, so like Skype meeting app is hitting this internet IP. I suppose if I wanted to go one layer deeper, we could resolve host name to maybe get a web address from that guy. And I got the ports. My local high order port to 443. So we got a nice SSL, lots of SSL connections here. Search UI, sounds like malware, I have no idea what that is. Skype host, well, I've got lots of, okay, so actually Skype host is talking to a couple things here. And it's just a way to visualize and really see the way stuff is talking to each other. And here's all my Chrome tabs talking to different websites.
Yeah, that search UI is actually the search bar in your taskbar. And even if you disable Cortana and the Windows search service, that search UI will still be running. And the reason I know that, I had somebody ask me, because that runs on servers if you have the GUI running, even though Cortana and the Windows search service are disabled by default.
Good to know. It's like, you always wonder when you see something like that on a server. You know, it's like, who installed that, right? Let's see. Well, okay. I've also got, every once in a while, I've got another advanced function here for those that are like diving deep into GraphViz or need to normalize your node IDs. And what I mean by that is I have a way to set a node format script so that every time you specify a node, it will go through this processor to normalize it. And I make a point of saying that because GraphViz itself is case sensitive. So if you have your nodes and your edges are related to each other in a case insensitive way, it's actually going to create way more nodes than you expect. So I added a set node format script as a way to create your own normalizers if you want to lower or do some other processing per node name. You can do that here. So let me run this one before I execute that, because what I did here is this W is lowercase, this one's uppercase, and this guy should inadvertently put both nodes on there. And if I can't get my data normalized before processing it, I can basically cheat and just tell PSGraph to normalize it for me and make all my nodes the same. So here, it basically lowercase everything, and it solves that annoyance when you have that mismatch. If it is easy to, and it's just a script block that runs again per node string. And if you need to set it back to default, just calling it again without a parameter, and I guess I don't have a set back to default dummy flag, I guess. But if you set no with no parameters, it does revert it back to the original. And I suppose my last big example here is, like, I love seeing stuff visually. And when I find the right set of data, sometimes issues will pop out at you that you just couldn't see without visualizing it. So I've got this ugly graph here. I'm really skipping over most of it just so I can run it, that walks through all of the help files. Looking at the related info at the bottom of Get Help. And we're going to graph showing how every command is related to every other command in the Microsoft PowerShell Management module. So this guy's, okay. This guy's really noisy, but as you zoom in on him, you kind of see some cool relationships. Like, we can see how we've got a cluster over here of stuff, and as I zoom in, it's all of the restart computer and restore computer type keywords that connect, you know? And then we go over here, we got a blur of stuff that connects to each other. Looks like random Windows management stuff. And then if I go over here, I got another cluster off on its own. That is the copy item, set item, rename item. And I thought this was kind of interesting to look at when I first generated it. But I noticed something odd on a specific cluster. So let me go find it here. The get item list here. Like, if I compare this to one beside it, like every node kind of talks to each other node. But when I get back over here to get content, I see many nodes talking to many nodes multiple times. In fact, in a weird way, I even see get content refer to itself twice. And I saw that, I'm like, wow, that's just kind of odd. So I thought, hey, let's go see what's going on, right? So let's go back over here, and we'll just do a get help, get content. And this is all I was kind of running and parsing. And sure enough, get content is related to get content, and it's related to get content. I'll have to put in a pull request for this one, but it's just one of the things that this has been in here for a long time, and I didn't notice it until I laid it all out in this nice visual way. So you never know what you're going to see in a set of data until you dive in and look at it from different angles. So that kind of covers the graph examples I had on hand, and I think I'd like to open up for questions from the audience here. So what do you guys think? Is this something you guys could see yourselves using or making use of?
Yeah, I mean, I can say I'm definitely see a use for this. I may actually start trying to use it tomorrow at work.
Kevin, I just wanted to say I've never joined this PowerShell user group before today. Brian actually Shoulder actually suggested that I join. I've utilized your module very, very heavily, so I'd like to thank you for all the work that you've put into it.
Oh, well, thank you.
I actually reported a lot of the bugs initially when you were first putting it out there.
I appreciate that. It helped me a lot, and I've got a new wave of bugs out there on just nuances I found this last 2 months as I was preparing this talk. And
yeah, I'm also the same one who put together that PS diagram script based off of your work here for PSGraph and GraphViz.
Oh, excellent. Well, thank you. I appreciate that. Like, I love seeing people use my tools. Like, I feel like not many people have seen or known, or this isn't on many people's radar yet. And that's why I thought I should talk about it a bit more, to kind of get more eyes on it, because it's helped me a lot. I really love using it.
Yeah. One of the nice things I liked about it, like you didn't really touch on in yours, but because of GraphViz has it capable in it, your script is capable of it too, is a lot of the inline HTML you can do for additional formatting.
Oh yeah, I've barely touched the surface of GraphViz, and I know there's a ton of great features just like that.
Mm-hmm.
That I haven't utilized yet, so I suppose I should, just so I can present on them, because you're right, I've seen the potential of those, but I suppose I've always done these things this way and haven't explored the rest of this mighty engine.
Yeah, it's really, really cool what this is all capable of when you know, basically my thing is just something that sits on top of yours.
Good, yeah, so yeah, keep the bug reports coming. I suppose for people that want to get started, I do. I think I have this documented pretty well. So here to pull up, say, my the GitHub page, which I've got a good tutorial to get started on that. And then where I kind of do the same quick breakdown of not only the commands, how to get started. So it's the same jumpstart I kind of went through today, probably a little bit quicker with different examples. And I also have a read the docs page set up where I try to cover as much as I can on that as well. So I'll leave these links back up on the screen. So I've tried to do my part in documenting as many of these features as possible. And I've got other examples like in this gallery. I took samples from the GraphViz gallery and recreated them as honestly as I could using the PSGraph module. So they had examples of just, random charts, but they also had things like state machines, how one state goes into the next state, and then I have the representative graphs with those as well. Relational data models, it's things that I've never worked with, but I was able to grab their examples and translate them quite authentically to my PSGraph. And I suppose that kind of wraps up my presentation here. Like I said, I'm the organizer for the Southern California PowerShell User Group. We're not doing stuff online interactively for many of them yet, but I'd like to offer remote connections like this once we're ready to. And I'm hoping to present this at the PowerShell Summit. I at least have submitted it. So I definitely would appreciate any feedback, good or bad, on the talk I just gave, because the feedback you give me will help me, show and share this with others that might be interested in it. So I guess with that, I guess any other questions? I think I've kind of covered everything that might be worth touching on here. Yeah, that's my list. So thank you everybody for joining the presentation.
Thank you, Kevin.
Thank you, Kevin.
Yeah, awesome presentation. Thank you.
Yeah, I agree.
I suppose we talked a little bit about DSLs, domain-specific languages, before, and mine is definitely an example of that. And it felt really dirty writing this module because I really had to abuse a lot of the best practices that PowerShell says, like parameter bindings. Like I've got positional parameters that are like sliding, and I'm trying to make it user-friendly versus, authentic PowerShell. And it's some of the most elegant but dirty code I've ever written. All right, well, thank you, everybody.